which of the following correctly shows trapezoidal approximation of the area under the curve represented by f of x is equal to 2/5 x squared minus 1/5 x plus 1 on the closed interval 0 through 8 using 4 subintervals. We're going to do this in 3 steps. Step number 1, we're going to find out the width of each subinterval. So delta x is equal to 8 minus 0 divided by 4, which is equal to 2. Step number 2, we divide the function into 4 trapezoids, each with equal width. So this purple line crudely represents the curve f of x. The first trapezoid will have an interval, will cover the interval 0 to 2, because the interval width is 2. Our second trapezoid also has an interval width of 2, so it's going to start at 2 and end at 4. Our third trapezoid also has an interval width of 2, so it starts at 4 and ends at 6. And finally, our fourth and final trapezoid, which also has an interval width of 2, will start at 6 and end at 8. Step number 3. We're going to set up the approximation using the area of trapezoids. So recall that the area of a trapezoid is equal to 1/2 times the height times the sum of the bases, or the parallel sides. A couple things to note. In this case, delta x is going to be h throughout this entire problem. Okay? So the interval width will actually be, I'll refer to that as the height. The sum of the bases will be the 2 parallel sides, and in this case, the parallel sides are running vertically up and down. So when we talk about the bases, kind of think maybe twisted. It's going to be the bases will be running up and down. So let's start off with the area of the first trapezoid. We have our 1/2 of h, and the vertical length from the x-axis to the curve of the first leg is f of 0, and the second leg is going to be from the x-axis to the curve will be f of 2. That takes care of our first trapezoid. The second trapezoid also has an area of 1/2 times the height. The leg, first parallel leg starting at 2 will have a vertical length of f of 2, and the second leg will have a vertical length f of 4. Moving on to our third trapezoid, the area still is going to be 1/2 times the height from the sum of the bases, but this one, the first parallel leg starts at f of 4, there's the vertical length, and the second length of the leg is f of 6 from the x-axis up to the curve. Our fourth and final trapezoid still has f times, or 1/2 times h. The first leg has a height f of 6 right here, and the second leg, the distance from the x-axis to the curve, is f of 8. One thing I want to point out is that you'll notice that the first trapezoid ends with f of 2, and the second trapezoid starts at f of 2. Those are the lengths of the 2 legs. In trapezoid number 3, it starts at f of 4, that's the height of that leg, where trapezoid number 2 finishes at f of 4. And trapezoid number 3, the height of the last leg ends at f of 6, where trapezoid number 4 starts there. So you'll notice there's a bit of overlap between the two. So when we add these areas together, okay, we're going to add all these areas up to find a total sum. We factor out our 1/2 times h, and keep in mind that the interval width is the same as the height of the trapezoid. So there's where my 2 comes from. So we have f of 0 plus 2 times f of 2, because it occurs twice, once in trapezoid 1 and trapezoid 2, plus 2 times f of 4, because f of 4 occurs once in trapezoid 2 and again in trapezoid 3. And then it's going to be 2 times f of 6, because you'll notice trapezoid 6 and trapezoid 4 both utilize f of 6, and we end on f of 8. So the correct formula, or the correct answer is going to be B.